Okay, next, about the introduction of discrete time signals. There are different ways of representing discrete time signals. There are basically 4 ways for representing discrete time signal. The first way is graphical representation. Means if you have a signal like this with time sequence -1, 0, 1, 2, here x of -1 equals to 0, x of 0 equals to 1, x of 1 equals to 2, x of 2 equals to 3. Here these 1, 2, 3 are amplitude, and here -1, 0, 1, 2 are time index. And the second way of representing the signals is functional representation. X of n equals to -2 for n equals to 2. This is another signal. Here -2, -1, 0, 1, 2. Here for n equals to -2, the amplitude of the signal is -2, and for n equals to -2, the amplitude of the signal is 2. And for n equals to -1, the amplitude of the signal is 1. For n equals to 0, it's 0, so we would represent the amplitude 0 by just placing a dot on the x-axis plane. No need to write here 0. And for n equals to 1, it is -1, so we go downwards in the negative axis. For n equals to 2, it is -2, which it can be represented like this, as it is not seen here. For 1, 2, -1 and -2. Okay, and the third way of representing signals is tabular form of representation. Here we write n here and x of n here, and we write all the possible time indexes -1, 0, -2, 0, 1, 2, and the possible amplitudes of the signal x of n, 0, 1, 2, 3, 4. And the next way of representation is sequence type of representation. Here we represent the amplitudes of the signal directly, -2, -1, 0, 1, 2, 3, and the origin or the time origin is presented by the arrow pointing towards the respective amplitude sequence amplitude. Here 0 is representing the 0 time index, and here 1 is representing and the right of the time origin will represent the positive time indexes 1, 2, 3 and so on, and the left of time origin will represent negative time indexes -1, -2 and so on. Okay.